The next example that we're going to look at is how can we make a game fair? All right, if we made a perfectly fair game, we want the winnings and the losses to be equal. All right, so a game is considered fair is if its expected value comes out to be 0 when we set it up. So that means in the long run, you're going to have some wins, you're going to have some losses, but after playing it many, many times or having many, many people play it, the gains and the losses will equal out. All right, they'll zero out. When you add up your losses, you add up your gains, you get 0. All right, so how do we set up our game? So we're figuring out how to set up a game to make it fair. All right, so if we have a card game, suppose a standard deck of cards, again, 52 cards in our standard deck. If it's a heart, I win. If it's not a heart, then I must pay $15. How much money should I collect? How much should my winnings be to make it fair, right? So the winnings have to come out bigger because the probability of winning is less than the probability of losing. All right, so when we want to make it fair, the expected winnings need to be 0. That means when I have the probability of winning times the profit we gain when we win, minus the probability of a loss times the amount we lose, it needs to equal 0. And so I want to figure this out. And so the part we're actually solving for is this. We want to figure out, well, how much should we pay out every time we win so that when we add up our winnings and our lossings based on averages, it comes out to 0. All right. And so the probability that we win, well, if we pull out a heart out of our standard decks, if you remember a heart, there are 13 of each suit. So there are 13 hearts out of 52. So there is a 13 out of 52, or 1/4, right? 1/4 of the deck is hard. So the chance of winning is 1/4 or 25% chance. We're looking for the profits. We don't know that, so I'm just going to let that be X because it's easy just to solve for X. So I want to solve for the profit. Probability of a loss. Well, if we have a 1/4 chance of winning, we should have a 3/4 chance of losing, right? 1 minus 1/4 is a 3/4 chance of losing. The loss, well, we pay out $15 when we lose. All right, so those are the values we're going to plug in, and we're going to set it equal to 0. So we have to do a little algebra here. We're going to solve an equation set equal to 0. All right, so we want to solve 0 is we want the average to come out to 0. Chance of winning is 1/4. We're looking for how much should our winnings be. So that's what we're looking for. We're going to solve for the profit, so that's my X. Minus the probability of loss, well, the chance of losing is 3/4. If we do lose, we have to pay out $15. All right, so this is what we have to solve. So we do have to do a little bit of algebra in this case. So the first thing I'm going to do is I'm going to take my 15 times my 3/4. Actually, and I'm going to go ahead and write my fraction here as a decimal 0.25. Just makes it a little easier when we go to solve this. All right, so, oops, I didn't mean to put an equal sign. That should be a minus. Take my 3/4 times my 15. Leave it exact, don't round, so it comes out exactly 11.25. 11.25. Move the 11.25 to the other side, so we add the 11.25. So we get 11.25 equals our 0.25 times our X, which represents our profit, and then divide by that quarter, 0.25. All right, so take 11.25 divided by 0.25, and then the answer will come out. The X value will solve. So it comes out 45, which means we should set the winnings, right, the profit. We should win $45. All right, in order for the game to be equal, we're going to lose more often than we're going to win. But when we win bigger than when we lose, right? 45 comes out bigger. So the wins, the positive amount's bigger even though it shows up less. If we average out, so if we play this game a bunch of times, or we have a bunch of people play it, we'll pay out 15 to loss. We'll win 15. It should average out to 0. And you should check it. Plug it back into this formula. If you're unsure, plug the 45 back into here. Take 1/4 times 45 minus 3/4 times 15. The answer should come out 0. So you can kind of check your answer that way. So in order for this game to be fair, because the odds of losing are greater than the odds of winning, you have to pay out more to make it a fair game. All right, and so we'll do more examples at the end, but that's the example of a fair game, figuring out a fair game.